What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 12, Section 2, the hyperbola. Let's do it. Define a hyperbola in terms of its foci. So if we look at a hyperbola going left and right, opening up like this, okay? And let's say we got a foci here and a foci here. So the definition of a hyperbola is all points such that, if I choose a point here on the hyperbola, such that the distance from here to here and the distance from here to here, if we take the difference of these two blue distances, we will get the same constant every time. So that is how you define a hyperbola in terms of its foci. Done. What must be true of the foci of a hyperbola? And so that's a little bit of an open-ended question, but basically what we can say, one thing we can say for sure is the foci, they have to be on the interior, right? These have to open up around the foci. The other element is that it must lie on this transverse axis, this axis coming right across. That's going to be the axis of symmetry for the hyperbola. So that's how you do it. Done. Where must the center of the hyperbola be relative to its foci? Well, if I look at a hyperbola again, going left and right, we could do the same thing going up and down. But if I look at my foci, let's say my foci are here and here. The center is right here, meaning if I connected these foci by a segment, the midpoint right here is going to be the center. And that's how you do it. Done. The question is whether or not this represents a hyperbola, and I would say yes, because it's something squared, x squared and y squared, and there's a minus, right? If it was a plus, it would be an ellipse. The only thing we need to change to put this in standard form is make that something squared, aka 6 squared, and then that, we take the square root of that and we write that squared, 3 squared, okay? And that is how you do it. Done. For this one to determine whether or not it's an ellipse, first we need to divide both sides by 400. So we're dividing everything by 400, like so. And then 25 over 400, that goes into it 16 times. So that becomes x squared over 16 minus, and then 16 goes into 425 times. So that becomes 1 over 25. So we got 25 like so, y squared, and then 400 divided by 400 is 1. Notice again, we always have a 1, just like in an ellipse on the right-hand side of the equation. Last but not least, we're going to take the square root of 16, which is 4, and just write it as 4 squared. That one we're going to write as 5 squared, and this is your standard form. Done. And this is your standard form, and obviously, just to answer that question, yes, this is indeed a hyperbola. It's x squared and it's a y squared, and there's a minus in between. So that is how you do it. Done. So for this one, it's basically in standard form. I'm just going to rewrite the 25 as 5 squared, and I'm going to rewrite the 36 as 6 squared. Now, the center, even though it's not asking for that, since it's x squared and y squared, we know the center is at 0, 0. Okay, so now we need to identify the vertices, okay? And first of all, is this going up or down or left or right? Well, because the x is in the front, it's going left and right, okay? So it's not about what is bigger, it's about which one's in front. So we know it's opening this way and this way with a center at 0, 0. So the question is, what is this point? What are these vertices, okay? Well, how far away do we go from these vertices? We look at this value right here, 5. So we go 5 to the right and 5 to the left, meaning the vertices are therefore negative 5, 0, and 5, 0. Now we need the foci. We know the foci are going to be in here on this transversal axis. And how do we get that? Well, we need to know our c value. And for hyperbolas, unlike ellipses, c squared equals a squared plus b squared, which are these values. So c squared equals 25 plus 36, right? And that simplifies to 61. So therefore, c is the square root of 61, right? c equals, we can say plus or minus rad 61. So now to get those foci, what we do is, and I'm going to combine it into kind of one coordinate, but it represents 2 coordinates, right? So since that transversal axis is going left and right, we take our center value of 0 and we add and subtract, or say plus or minus rad 61, and then the y value stays at 0. Now the last thing we need are the equations of the asymptotes. And the equations of the asymptotes, we know that they go through that center, right? And they come like this. So we can pretty much use point slope and these values to come up with the equation, okay? Because they both share 0, 0. And what is the slope? Well, going this way, right? These values are going to become very important because we're going for, and I'm talking about this one with the positive slope. We're going to the right by 5, and then we're going up by 6. Now, I didn't write it in there, but that's what's happening. This is related to that slope. So my slope of one of them is 5 over 6, and in point slope, we do y minus 0 because that point is included, so that's just y, equals my slope, which again is going up 6 over 5, so positive 6/5 times x. And again, we don't need a y-intercept because it's, again, would be plus 0. So it's centered at the origin. And then for this other one coming down the other way, now what are we doing? We're going to the left by 5, negative 5, and then up 6. So that asymptote will be y equals negative 6/5 x. Same exact thing, except we have a negative slope. So that is how you do it. Done. So for this one, we got the y squared in front. So that just is going to tell us that this is going to go up and down. I also know since it's just y squared and x squared and there's nothing up there other than those two variables, we know the center is going to be at 0, 0. That means the vertex is going to be above and below 0, 0. So we're changing the vertices, we're changing that y value. And I know that because, you know, again, like I said, it's going up and down. So that's where the vertices are going to go up and down. And here, you know, how do we get that the distance up and the distance down? Actually, I got to put this in standard form. So when I do that, I just change that to 2 squared, and I change the 81 to 9 squared, and that equals 1, okay? And we can use that 2 value because that's what's happening. The vertex is going up to one of them, and the other one is going down to negative 2. And now to get the foci. So to get the foci, I need to use my equation c squared equals a squared, 2 squared, plus b squared, 9 squared. And those are interchangeable, right? And then c squared is 4 plus 81. C squared is 85, aka c is the square root of 85. And again, the foci are going to be approximately here and here, right on the inside. So that means we're adding it again to the y value of the center, going up and down. So my foci will be, let's write it over here. We got foci at the x value staying at 0. The y value is going to be plus or minus rad 85. Okay, now we need the equation of the asymptotes. And again, the asymptotes are going to look like this. And since they both go through 0, 0, all we need to know is the slope of these lines, okay? So once again, looking back at this equation, we see that we're going up a distance of 2, but then how much are we going to the right? What's the slope? Well, since there's a 9 squared underneath here, that means we're going to the right by 9. So that's a rise of 2, a run of 9. So that means my one equation is 2/9 x. And again, because it has a y-intercept of 0, 0, I don't need anything else. The second one is that, but just negated, right? The opposite slope, negative 2/9 x. That's how you do it. Done. So for this one, let's first get our center here. That's going to make things easier. So the center is at 1, 2. And because the x is first, it means it's going left and right like so. So here we're going to put that center in at 1, 2. And I'm going to reformat that to get it into standard form. So x minus 1 squared over 3 squared minus y minus 2 squared over 4 squared. And this is now going to equal 1, of course. And we can see that since the x is first and these vertices are going to be out here and here, what's the distance that we're going from the center? It's going to be 3, right? It's this value right here. So we're going to go 3 out this way, 3 out this way. That means the vertices are going to be starting from the center at 1, 2. I'm going to add 3 to the x, so we're going to get 4, 2. And then I'm going to subtract 3 from the x, and we're going to get negative 2. And now to get the foci, we need our equation c squared equals this plus this, 9 plus 16. C squared is therefore 25. That means our foci, right, is going to, by the way, square root, and we get c is equal to 5. That's what we're going to use to get our foci. So our foci, they're going to be 5 to the left and right of that center. So my foci, and I'll write it out as two different coordinates this time, because 5 is easy to plug in. So we add 5, we get 6, 2. We subtract 5, we get negative 4, 2. Last but not least, we need the equation of the asymptotes. And the asymptotes are going to be these diagonal lines here. And we got a point, so we're going to use point slope, 1, 2. But the question is, what's the slope? Well, I'm going 3 to the right, and how much am I going up? That value underneath the y, 4 up. So my slope is 4 over 3. So in point slope, first I could say y minus 2 equals 4/3 times x minus 1. And for the other asymptote, it's the same point, but now it's negative 4/3 times x minus 1. All they did in the answers is then they added 2 to this side. Same thing here, added 2 to this side and got rid of those minus 2's like that, but it's the same thing. But anyways, that is how you do it. Done. So for this one, we're going to start with the center, which is at positive 2, negative 7. Then I'm going to put that in the nice standard form. And I'm just going to make that 49 7 squared, make this one 7 squared as well. So again, we have the x in front. That means we're going left to right. We've got a center at 2, negative 7. And now we have these values. And this means that 7 away from that center, both left and right, are the vertices. That means we have a vertex at 2 plus 7, which is 9, comma negative 7, 2 minus 7, which is negative 5, comma negative 7. And now to get the foci, we use c squared is equal to that plus that, 49 plus 49, which is 98. So c is the square root of 98, which simplifies to 7 rad 2. So then my foci is going to be at, and again, it's on this, it's going to be out here and out here on this transversal axis on the x-axis going left and right. So we got 2 plus or minus, that's 7 rad 2, comma negative 7. Last but not least, we need the equation of those asymptotes, which go like this and like this. And so since we got that nice point there of 2, negative 7, all we need to do is calculate the slope. I already see it goes across 7. How much does it go up? It goes up this value underneath the y. It goes up 7 as well. So that's a slope of 1. So that's pretty nice. So for my asymptotes, my slope is 7 over 7, or 1, as I said. So it's y plus 7, because it's y minus that negative 7, equals 1 times x minus 2. Notice I didn't write the 1, because what's the point? And for the second equation, it's going to be y plus 7 equals, and then we have negative 1 times x minus 2. Here I am going to write the negative 1, and I am going to put it in parentheses, because we have to distribute that negative 1. And then this one becomes y equals negative x, and then negative 1 times negative 2 is positive 2, minus 7 is negative 5. So this is one equation for the asymptote. The other one is here, that's fine. But just to get it like the back of the book, we're going to minus 7 from both sides, and we get y is equal to x minus 9. So those are the equations. That's everything. That's how you do it. Done. All right, so for this one, before we can begin anything, we need to get it into our standard form. So the way we're going to do that is I'm going to start by subtracting 81 from both sides, and then I'm going to do a little grouping, okay? I'm going to group these two together, and we're going to factor out the leading coefficient of that x squared and y squared. So here, it's going to be a negative 9, and then we got x squared plus 6x. Okay, and we're going to leave a little bit of room. And then over here, we're going to factor out a positive 9, and then we got y squared minus 6y, and then again, a little bit of room, and set that equal to negative 81. Okay, next, what we're going to do is we're going to complete the square. So I'm going to take half of the b and square it. So half of 6 is 3 squared is 9, so I'm going to add that here. Same thing here, negative 3 is half of that squared is 9. And then but if we add it to the left side, we must add it to the right side. But remember, we're really adding a negative 81, right? Negative 9 times 9 and a positive 81. So we got negative 81 and positive 81. These two are going to cancel out. And now we have negative 81 on this side, and that's equal to negative 9. And then we can factor this. So that's the idea. We create a perfect square. That becomes x plus 3 squared. This one becomes plus 9 times y minus 3 squared. Okay, last step, we want a 1 over here. So we're going to divide everything by negative 81 like this, boom and boom. And then this is going to cancel out, reduce to a 1. That's what we want. Okay, now this is going to be 9 over negative 81. That's going to cancel out to 1 over 9, but it's negative. So we got y minus 3 squared over 9, and it's negative, so we can put a minus in front. And then these two cancel out to 1 over 81. Negatives go away. So we got x plus 3 squared also over 9. And that's how you do it. Now we're in that nice standard form. I could say 3 squared instead of 9, but either way. The only thing I can change is I'll change the 9 to 3 squared, and we're good to go. Okay, so now we can find all the important pieces. So first thing I like to find is the center, even if it doesn't explicitly ask for it, because we can use the center to find everything else. So the center is going to be the opposite of that and the opposite of that, which is negative 3, comma 3. And then we can also think about, like, what does this look like? Does it go left, right, or up, down? Since the x is in front, it's going to go like this, just so we get a rough image. It's going to go left, right. And we know we have a center at -3, 3. Okay, and then the vertices are going to be out here and here. And the question is, how far away are they from the center? Well, we look at this value underneath the x, and it's 3. So that means it's 3 to the right, 3 to the left. So 3 to the left from -3 is -6. 3 to the right would be +3, which is 0, 3. And then to get the foci, we need our c value. So c squared is equal to that plus that. A squared plus b squared, right? So that's 9 plus 9, which is 18, which means c is the square root of 18, which simplifies to 3 rad 2, okay? So now to get the foci, remember, the foci are in here. They're inside sort of those curves. They bend around them. So you go from the center, and what are we adding it to? Well, again, it's going left, right. So it's on that transversal axis. We're adding it to the x value. So the foci here, we can kind of put it over here. Foci, and I'm going to kind of put both of them in one. We're starting at that center of -3, and then I'm adding that c value, where is it, plus or minus 3 rad 2, to that x value, and keeping the y value, the 3, the same. Okay, the last step is to find the equations of the asymptotes. And again, the asymptotes are going to look like this, right? These diagonal invisible boundaries. And the way we can do that is, remember, they share both asymptotes, that common point of -3, 3, and then we got to figure out what's the slope. Well, we know the slope because these values give us the slope. The value under the x is how far it goes to the right. The value under the y is how far it goes up. So it's literally 3/3 for this positive one, right? 3/3 is a slope of 1. Using point slope, we'll say y -3 is equal to 1 times, I won't include the 1, x minus -3, which is x plus 3, okay? And then to get into slope-intercept form, we add 3 to both sides, y equals x plus 6, okay? So that's one of them. And then the other one is the exact same point, so it's still y minus 3 equals, but then now the slope is the negative version, so it's -1 times x plus 3. So as we distribute that, it becomes -x minus 3, okay? And that means the -3 is on both sides are going to cancel out, which means the other one is just y equals -x. So those are your equations of the asymptotes. That's how you do it. Done. So for this one, before we start, we got to get it into our standard form. So I'm going to start by moving the 156 over to the other side, making it -156. And then over here, we're going to kind of group the x's, group the y's, and factor out the leading coefficient. So here I'm going to factor out that -4 for the x squared, for the x's. So I got -4 times x squared minus 6x, right? Divide that by -4, we get -6, and then I'll leave a little bit of room. And then over here, we're going to factor out that 16. So we got 16 times y squared minus 8 times 16 is 128, so minus 8y. And then again, we'll leave a little bit of room. Okay, the next step to get this into our good standard form is we got to complete the square. And we do that by taking half of that and squaring it. So that's -3 squared is 9. -4 squared here would be 16. But then we got to add these values to the other side, remembering this is really -36 that we're adding here. And 16 times 16 is positive 256 that we're adding here. So 256 minus 156 is 100, minus 36 is 64. And then over here, that becomes 16 times, and then this factors to y minus 4 squared, and that factors to x minus 3 squared, okay? And then our last step, we divide everything by 64, like so, and like so, and we're almost there, okay? So this is going to turn into a 1. 16 over 64 reduces to 1 over 4. -4 over 64 reduces to -1 over 16. Okay, I'm going to do one last thing as I write it for the final time. I'm going to swap these guys, and then I'll also simultaneously write 16 as something squared, 4 as something squared. So watch this. Y minus 4 squared over, instead of 4, I'm going to say 2 squared. That's more of a formality again. They're the same thing, but this is just how we like to do it in standard form. And then I'm going to put this one second because it's negative, right? So minus x minus 3 squared over 16, and that equals 1. Now we're going to begin with the center. The center is at 3, 4, right? The opposite of this and the opposite of this. And then now which way is this facing, right? Since the y is in front, it's going to go up, down like this. We're going to do just a little graph like that. So we got our center here at 3, 4. And then where are the vertices, right? It's going up to here and down to here, okay? So what is that distance? Well, that distance from the center to those vertices is whatever's under the y, which is 2. So that means we're going up 2, so 4 plus 2 is 6, and then down to 4 minus 2 is 2. So we got center, vertices. Then we need the foci. The foci are in the middle, so they're in here. And we got to figure out the c value that we add to the center to get to those foci. What's our equation for c? C squared equals, oh, and I forgot to write this as 4 squared. I just realized that. That should be 4 squared, not 16. C squared is the sum of this and this. So that's 4 plus 16, which is 20. So that means c is the square root of 20, and that is 2 rad 5 when you simplify it. Okay, so that means the foci then can be written, and we can kind of consolidate it. And again, since it's going up and down, we know the foci is going to now, the c value is going to affect the y. So we know the 3 stays as is, and then we take that 4 plus or minus 2 rad 5. Okay, now the last thing we have to do is come up with the equations for the asymptotes. Again, the asymptotes are going to look like this and like this, these invisible lines that are going to come through that 0.34. And that's important because we're going to use point slope. But the thing is, I need to know the slope. What is the slope? Well, looking back at this, you can see that going along, this provides the slope of these asymptotes. That's under the y, so that's the rise. This is under the x, so that's the run. So it's rise over run 2 over 4. That's the positive version, of course. So using point slope, I have y minus 4 is equal to the slope, which is 2 over 4, which will be 1/2 times x minus 3. Okay, and then for the other asymptote, we just negate that 1/2. And all they did in the answers to modify this is they added the 4 to this side, added the 4 to this side. But it's the exact same thing. So here are the final equations for the asymptotes, center, vertices, and foci. That's how you do it. Done. So for this one, we got to start by getting it into our nice standard format. The first step is to subtract 2401 from both sides, get that constant over there. Then I'm going to kind of group these and these together, and I'm going to factor out a leading coefficient if there is one. But for the x squared, there is not. So we just leave that as is. I'm still going to put some parentheses around it just to remind us that we need to complete the square there. For the y, I can factor out negative 100, and then I got y squared plus 10y. And then we make some room for completing the square. Okay, so now to complete the square, I take half of this term and square it and add it. So I'm adding 1, but I'm adding 1 here. I must also add 1 here. For this one, I take half of that, which is 5, square it, and that is 25. But remember here, I'm not just adding 25, I'm adding 25 times negative 100. So that's negative 2500, so I have to put that here as well. So now adding everything together, on the left side, we get negative 4900. And then on the left-hand side, we get this, which you can factor to become x plus 1 squared. And then this one, negative 100 times that factors to y plus 5 squared. All right, next what we're going to do is we're going to get the right side to equal 1. So divide everything by negative 4900. That's going to turn into a 1. Those double zeros are going to cancel out with those guys. And this is going to turn positive as well. So now let's reformat this. And I'm going to put this one in front because now that's the positive one. So we have 1y plus 5 squared over, and that's just a 49. Again, I'm going to write it as 7 squared. Minus, and then it's this, right? It's x plus 1 squared over 4900, but I'm going to write that as 70 squared because that's what 70 squared is, 4900. And this equals 1. There's our nice standard form. Now let's do our thing. First, let's get the center. Center is really helpful even though they don't ask for it. It's the opposite of this and the opposite of that. So it's negative 1 for the x, negative 5 for the y. And then the vertices, okay? Let's think about what this first looks like. Since the y is in front, it's going up, down like this. And that center, as we mentioned, is at negative 1, negative 5. So we're going up to the vertex, down to the vertex, up and down. And how much are we going up and down by? This value. So the vertices are -1, comma, -5 plus 7 is 2. And then we got -1, -5 minus 7, which is -12. Great. And where are the foci? The foci are going to be up here inside these two curves. And we get there by, we have to find a C value. Okay, so what's our C value? C squared is equal to this plus this. All right. So that's 49 plus 4900, which is 4949. And then we take the square root of both sides. And that ends up simplifying to 7 rad 101. Okay. And so then the foci are again going to add to the y value of the center, just like we did for the vertices. So it's going to be -1 stays as is, and then it's -5 plus or minus that 7 rad 101. Okay. Last but not least, we need to come up with the equations of the asymptotes, which look like this and like this. You know, again, this is not drawn to scale, just to give you a rough idea. And using point slope, I can start by saying y minus -5, which is +5, is equal to the slope. What is the slope? Well, this is under the y, that's the rise. This is under the x, that's the run. So 7 over 70, which is 1/10, and then times x minus the x value of the center, which is x minus -1 or x plus 1. And then for the second one, it's the exact same thing. Y plus 5 equals, but then the slope is -1/10. Times x plus 1. And then likely in the back of the book, the only difference that they did was they minus 5 to the other side. So they have y equals 1/10 x plus 1 minus 5. And then y equals -1/10 x plus 1 minus 5. So here are your final answers for the asymptotes, these two equations. And there's the vertices, foci. That's how you do it. Done. So for this one, we want to start by getting it into our nice standard form. First, I'm going to add 464 to the other side. And then I'm going to group these two together and these two together. And we're going to factor out those leading coefficients. So for the x's, I'm going to factor out the 4. And then we got x squared plus 6x, right, dividing both by 4. And then we'll leave a little bit of room. For the y squareds, I'm going to factor out the -25. And then we have y squared minus 8y, right? -8 times -25 brings us back to 200. Okay, now we're going to complete the square. And I'm going to take half of that and square it, which is 3 squared, which is 9. Add it here. Half of the -8, which is -4 squared, which is 16. But then we also have to add it to the right-hand side. And remember, we're adding 4 times 9, which is 36, and -25 times 16, which is -400. Now, when we say -400 plus 464 is 64 plus 36 is 100. So we got 100 is equal to, and then let's factor these guys. That becomes x plus 3 squared. This becomes y minus 4 squared, right? That's what that factors to. Okay, now last step, we're going to divide everything by 100. Boom, boom, and boom. And then this is going to simplify to 1 over 25. This is going to simplify to 1 over 4. Okay, I'm going to rewrite this as x plus 3 squared. And then I'm going to rewrite 25 as 5 squared. Minus y minus 4 squared. Rewrite the 4 as 2 squared, okay, because it's valid, it's the same. And in our standard form, we'd like to write it as something squared, okay? And then 100 over 100 is 1. Now let's do our thing. First, what is the center of this parabola? Opposite of that, opposite of that. That's going to be -3, 4. What are the vertices? Okay, well, let's look at this hyperbola. First of all, the x is in the front. That means it's going left and it's going right, like so, okay? And that means our center's right here at -3, 4. So the vertices are going out to the left and to the right, right? They're right there. And how much do they go left and right? That value, meaning 5. So the vertices are 5 plus -3, which is 2, and -3 minus 5, which is -8, comma 4. And then to get the foci, which are in here and here, we have to figure out our c value. C squared is equal to this plus this, 25 plus 4, which is 29. So that means c is equal to the square root of 29, right? So to get the foci, we take our center, and since it's going left, right, we add it to the x value. So -3 plus or minus rad 29, comma, whatever that center y value is, which is 4. Okay. Last but not least, we need to get the equations for the asymptotes. So the asymptotes go through that center like so. But the question is, what is the slope, right? We can use point slope, but what is the slope? We can go, it's this value is the run, that's the rise, because that's under the x, that's under the y. So we're going to the right by 5, we're going up by 2, meaning my slope is 2/5. Okay. So let's see if we can make some room. Let's do it right here. So we got y minus the center 4 is equal to that slope of 2/5 for the positive version, times x minus -3, which is x plus 3. And then just to get it how they have it in the back of the book, we're just going to add 4 to the other side. Y equals 2/5 times x plus 3 plus 4. Okay, and then the other one is the exact same as this. It's the exact same point, but the slope is negative instead of positive. So negative 2/5, x plus 3 plus 4, like that. So these are the equations of the asymptote. Sorry, it's so scrunched together. And there's everything else. That's how you do it. Done. So for this one, we're just finding the equations of the asymptotes. So this is pretty cool, actually, because if you just imagine what this looks like, it's going left to right. And that's because the x is in front. And then my center is the opposite of that, meaning it's +3, -4. So this is really great just to start getting an image in your mind of like what the asymptotes are. They're lines that go through that center, like in this way, kind of hugging the asymptote. And we already have a point. All we need is the slope. How do we get the slope? This is the rise. Whatever value is under the y, this is the run, meaning the slope is that over that, or 2/5. Okay, and that's for the positive version. For the negative version, it's the same slope, but it's -2/5. Okay, so now let's use that to build our line. So the first one, using point slope y minus -4, which is y plus 4, is equal to 2/5 times x and then minus that 3. And then what they like to do in the back of the book is they just move that 4 over. So they make it y equals 2/5 x minus 3 minus 4. And then the second asymptote is the exact same in terms of the x minus 3 and the minus 4, because it's using the same point, but the slope is negative, so we just change that to -2/5. That's how you do it. Done. So for this one, we have to first get it into standard form before we can figure out the asymptote. So I'm going to add 151 to the other side, and then I'm going to take these two and factor out those leading coefficients. So here, I'm going to factor the 9 out of the x's. So we got x squared minus 2x, and then leave a little bit of room. Plus here, factor out a -16, and then we got y squared minus 2y, right? And then leave a little bit of room. Okay, now we're going to complete the square. So I'm going to take half of this and square it, which is 1. Half of this and square it, that's also 1. And then we're going to add the same to the other side. But remember, that's really a 9 times 1 and a -16 times 1. So we're adding 9 and -16. Okay. So now on the right-hand side, this simplifies to, we've got 9 plus -16 is -7, and then -7 take away from that is 144. So we got 144 is equal to, and then -16, that factors to y minus 1 squared. This one factors to the same thing, x minus 1 squared. Okay, great. Last step, divide everything by 144, and by 144. 9 goes into 144 16 times, so this is really 16. But again, we normally like to write it as 4 squared underneath. 16, again, goes into 144 9 times, so that reduces to 9 on the bottom, which we can rewrite as 3 squared. And now we see that we got a center at 1, 1, right? The opposites of those. And that's important because that's the point we're going to use in these equations. And now here's my slope, right? Rise of 3, run of 4. So what we can do with that is I can say y in point slope y minus 1 equals a slope of +3/4. That's one of the asymptotes, times x minus 1, right, from that center value. And then all we're going to do is, just to get it like the back of the book, we're going to add 1 to the other side. So y equals 3/4 x minus 1 plus 1. And then the other equation is the exact same. We just negate that slope. -3/4 x minus 1 plus 1. And that is how you do it. Done. So for this one to graph it, remember the first thing I'm noticing is I got x in front of the y, and that means it's going to go this way and this way. Okay, that's just the first thing to note. Then where's the center? Well, it's x squared and y squared. That means the center is actually at 0, 0. Technically not part of the hyperbola, but I'm going to put it in there. And then I want to get that vertice, right? The vertices. And since I know it's going left, right, I got to look at this value. And 49 is really 7 squared. Y squared is really, or 16 is really 4 squared. So the significance of that is that 7 means starting at my center, I go left 7 right here and right 7 right there to get the vertices. Now to get the foci, I need to know what c is, and the equation is c squared equals this plus this, 49 plus 16, which is 65. And that means c is equal to the square root of 65. And that means my foci, again, going left and right on that same axis, are plus or minus rad 65, comma 0, right? Same as that y coordinate for the center. So square root of 65 is pretty close to 8. So I'd say my foci would be here and right here. Approximately 8 and approximately -8. And then now to graph it, if we want like a pretty precise graph, okay, we can put in the asymptotes. They don't have this in the back of the book, but I'm just going to show you how you can sort of use the asymptotes. Since we already know the slope will be 4/7, right, starting from the center point, that means we're going up 4, and I know these are in 2, but it's like I'm doubling it. So we're going up 4 over by 7. So there's one asymptote, and then the other way down 4 over 7, so -4/7. And this just makes it easy to now graph it from the vertex, and then I always say we kind of hug the asymptotes. We kind of go up like this, hug the asymptote, kind of go down like that. So that just helps us to give it some nice shape. And we go like this and like that. And that's it. That's how you graph it. Done. So for this one, first, I want to reformat this to be y squared over 3 squared, okay, minus 25 can be rewritten as 5 squared. Okay, now we got it in that nice standard form. We know our center is going to be at 0, 0, because it would be whatever y is minusing or x is minusing for the coordinates. But since there's nothing up there, it's 0, 0. And then we can figure out that since the y is in front, it's going up and down, okay? Now let's find the vertices. So the vertices, since we know we're going up and down, we use this value, 3, to go up and down that amount to that y value. So it's going to be 0, +3, and 0, -3. Now let's get the foci. So the foci, we need our c value. C can be gotten from this equation. C squared equals this plus this, 9 plus 25, which is 34. Therefore, c is the square root of 34. And since we know it's going up and down, we add that to the y value of the center. So it's 0, 0 plus and minus, or minus, that rad 34, okay? And square root of 34, it's pretty close to 6, right? Square root of 36 is 6, so we can say right around here for the foci. And then now I'm going to create my asymptote lines, and that's only because it's going to help us sketch this out a little bit further. It doesn't ask for that, but I do think it's nice because we can go through that center, 0, 0, and then apply a slope of 3 over 5 because of those values. So up 3 over 5 like so. And then coming back the other way, it's just -3 over 5. And then now we just connect the dots. So we got the vertices, and then we kind of come out and hug the asymptotes like that. Hug the asymptotes like this. And it's not supposed to cross, by the way, if it looks like it did. That was an accident. And then hug the asymptotes and hug the asymptotes. And that's how you do it. Done. So for this one, we're going to start by recognizing that the center is at the opposite of that, which is 4, and the opposite of that, which is -5. So that's our center, and that's right here. And then we recognize that because the y is in front, it's going to be going up and down like that. And so where would those vertices be? Well, if we're going up by this amount, basically the square root of that amount, I should say, up and down by that amount, we can say we got 4, and then -5 plus 3 is -2, and then we also have 4, -5 minus 3 is -8. So our vertices are going to be 4, -2, and 4, -8. And then now to get the foci, we need our c value. Again, c squared is going to equal to that plus that right? So 9 plus 25 is 34, which means c equals square root of 34. That's approximately 6, by the way. And then the foci, again, going up and down, are going to be that same x value, and then -5 plus or minus square root of 34. So there's our foci, here's our vertices. And then now it's not asking for the equation of the asymptotes, but I'm going to graph the asymptotes anyways. We know we're going through the center, and we can figure out the slope by taking the square root of that 9, which is 3, the square root of that 25, which is 5. And that tells me that my slope is, I'm going up 3 over 5. So up 3 over 5. So there we got an approximate line. And then the other way is -3 over 5. And then once we've got those, we start at the vertices and we just hug the asymptotes. Boom. Hug the asymptotes. Boom. And we do the same coming down here. Hug the asymptotes. And you see we're going around those foci, which is what we want. That's how you do it. Done. So this one, we're going to start off by acknowledging that the center is the opposite of that 3, the opposite of that, which is 3. So our center is at 3, 3. And since the y is first, we know it's going up, down like this. So now, to get the vertices, okay, we're going to go above and below, again, because it's going up and down. So we're going up and down by the square root of 9, which is 3. So we're going to have 3, and then we're adding 3 to that, which is 6. And then we've got 3, and we're minusing 3 from that, which is 0. So our vertices are here and here. And then we need our foci, which are going to be, we got to get our c value, which is c squared is equal to that plus that, which is 18, meaning c is the square root of that, which simplifies to 3 rad 2. And so since it's going up and down, right, we know we take that c value and we add it to the y value of the center. So 3, 3 plus and minus 3 rad 2. And that's approximately 4.24. So plus 3 is going to be 7.24. And then down here, it's going to be -1.24. And last but not least, we're going to take this center and we're going to apply the slope. The slope is going to be 3 for the rise, and then the square root of that for the run, which is also 3. So 3 over 3. So that's a nice slope of 1. That's pretty easy to graph. So that's 1, and the other is -1. And again, we use the asymptotes just to guide the hyperbola. So starting at the vertex, we kind of go like this and hug the asymptotes. Boom, boom. And we do the same down here. Hug the asymptotes. Boom. Shouldn't cross it. I kind of crossed it, but I didn't mean to. It's meant to go right in the inside. So anyways, that is approximately how you do it. Done. So for this one, our first step is to get this into our nice standard form. I'm going to do that by first adding 109 to the other side. And then I'm going to kind of group these guys, this one and these two together. Now, there's no leading coefficient for the x squared, so we'll just say x squared minus 8x kind of by itself over there. And then here, we're going to factor out that -25, and we got y squared plus 4y in here. We're going to leave a little bit of room because we're now going to complete the square. So we're going to do that for the x's first. We're going to add half of this value, which is -4 squared, which is 16. We're also going to add it to this side, right? It's got to be balanced. And then half of this value, which is 2 squared, is 4. But remember that this 4 is really multiplied by -25. So it's -100 that we must add to the right-hand side. Okay, now let's simplify a little bit. And by the way, we're going to factor this guy, right? That's why we made that perfect square. So that's going to be x minus 4 squared. This is going to be minus 25 times y plus 2 squared when we factor it. And that's equal to -100 plus 109 is 9 plus 16 is 25. Last step to get this into standard form, divide everything by 25. Boom, boom, and boom. And this is going to cancel out to a 1. Same with this. So our final form is 1 equals, we'll say y plus 2 squared over, and I'm going to say that's cancel out to a 1, but I'm still going to put it over 1 squared, and then minus, and then here we're going to have x minus 4 squared over 25, which is the same as 5 squared. Okay, great. Now we have a lot of good information. First, we know the center is the opposite of that, and that which is 4, -2. We also can get the vertices, okay, because if we got a center at 4, -2, which is right here, and we know that x is in front, we know that this thing is going this way and this way. So to get to those main vertices, I'm going to take this value, 5, and I'm going to add it to the x because it's going left and right. So we're going to say we got 9, -2, right, adding 5, and then subtracting 5, -1, -2, okay? So we got 9, -2, and -1, -2. There are my vertices. And now let's get the foci. Let's see if we can get some room here. And we need to get my c squared equals this plus this. That's 25 plus 1, which is 26, which means c equals the square root of 26. So to get the foci, we don't have a lot of room here, but I can fit it in right here. Again, we're adding that c value, which is the square root of 26. We're adding it to the x values, because once again, this is going left, right? So that is going to be from the center. So 4 plus or minus rad 26, comma, and then we have the same y value, -2. So that's going to be just a touch more, because square root of 26 is about 5. So it's going to be like right here, let's say. Okay, right here. That's just an approximation. So again, here are the vertices, boom and boom, and we already got those points there. And then the foci is approximately -1.1, -2, and 9.1, -2, just approximately. And last but not least, we're going to put in the asymptotes, okay? So I know I got a point here, and the asymptotes are going to have a rise of 1, because that's under the y, a run of 5, because that's under the x. So from this center, we're going up 1 over 5 like so. And then coming down the other way with a -1/5 through that same point. And now we can gotta get it in there. So it's gonna be tight. We gotta hug those asymptotes. So we go blop like that and come around the foci, right? Like that. And then this side from that vertex, we're gonna go around like this and come around like that. That is how you do it. Done. For this one, we got to start off by getting it into standard form. So I'm going to add 656 to the other side. We're going to do it down here. So that's positive 656. Then we're going to group these guys and factor out those leading coefficients. So I'm going to factor out a 64 out of the x squared and x. So that's going to be x squared plus 2x, and then leave a little bit of room. Over here, we're going to factor out a -9. So I'm going to make that actually -9 times y squared plus 8y, right? -9 times 8 brings us back to -72, and leave a little bit of room. And now we're going to complete the square by taking half of this and squaring it, which is 1, half of this, which is 4, and squaring that, which is 16. But we must add the same values to the other side, remembering that this is really 64 times 1, which is 64, and this is really -9 times 16, which is -144. So -144 plus 64 is -80, plus 656 is going to be 576, and this is going to equal -9 times y plus 4 squared, and this is going to be 64 times x plus 1 squared. Last but not least, we're going to divide both sides by 576 to get that nice 1 on the right-hand side, which is what we want. And then we got 1 is equal to 9 goes into 576 64 times, so that reduces to 64. 64 goes in 9 times, okay? So that's going to be a 9 and a 1 on top. So now we can rewrite it as x plus 1 squared over 9, which is the same as 3 squared. That gives us that nice standard form, minus y plus 4 squared over 64, which is the same as 8 squared. Now we got plenty of information to begin. So first we have a center at the opposite of those two, which is -1, -4. And we've got vertices that'll be going left and right from the center because the x is in front. So the parabola is going like this, approximately, right? So how much do we go left and right? This value, 3. So we go 3 left, which makes it -4, -4, 3 right, adding 3 to that, which makes it 2, -4. Now to get the foci, we need to find our c value, c squared. Here, let's write it down here. C squared equals 9 plus 64, which is 73. So that means c equals rad 73. And therefore, the foci is starting at the center, -1 plus or minus that c value, rad 73, comma, -4. How did I know I'm adding it to the x and not the y? Because we already said it's going left, right. And this is approximately 8.5. Let's just say approximately. So we got a focus here of 7.54, comma, -4, and then we get another foci approximately here at -9.54, comma, -4. Now I'm going to plot the asymptotes. Even though it doesn't ask us to, it makes it easier to plot the graph. So we know we're starting at this center point right here, and then the slope of the asymptotes is 8 over 3. It's those two values, rise over run, because again, this is under the y, that's under the x. So we're going up 8 over 3. And then on the other side, it's that same slope, but negative. And again, these are just approximations so we can get a nice graph. Then starting at the vertices, we go up and we hug those asymptotes, boom, and coming down, boom. Obviously not meaning to cross the asymptote, and then bending around that focus. And then same on this side, boom and boom. And that's how you do it. Done. For this one, we have to start by getting this into the nice standard form. So first I'm going to add that constant to the other side, 2575, and I'm going to set this equal to this with factoring out that leading coefficient here and here. So for the x's, I can factor out negative 100, and then I get x squared minus 10x, and then we're going to leave room there. And then for the y, there is no leading coefficient, which is nice, so we can just say y squared minus 10y. Okay, now we're going to complete the square, and we're going to do that by taking half of this and squaring it, which is negative 5 squared is 25. And here's again negative 5 squared, which is 25. And then we have to add this 25 over here, but then remembering that this 25 is really times negative 100, which is negative 2500. And then when you combine everything, you get 2600 minus 2500, which is 100. And this equals, when you factor this, y minus 5 squared, and this equals negative 100 times x minus 5 squared. Okay, and these are being added together. Last but not least, we're going to divide everything by 100, divide by 100, divide by 100. These are going to cancel out, but there's still going to be a negative there. And now I'm going to rewrite this one last time. So we got 1 over here, which is what we want. I'm going to move the x to the right because that's the minus, and I like the minus over here. Remembering that that's the second term, and so since this is the first term, it's going to be going up, down. But anyways, that's over 1, so I'm going to write that as 1 squared. 1 and 1 squared are the same. And then minus, and then here we have y minus 5 squared over 100, which is the same as 10 squared. Again, that's just to get us in that nice standard form. It's easier to analyze this equation as such. Now we know what the center is, right? The center is the opposite of these two, which is just 5, 5, all right? And then the vertices, well, first, if we remember that this is at 5, 5, right? Here's the center. And we know this is going up, down, right? The vertices are going to be above and below by this amount, meaning we're going up by 10 and also down by 10 to get vertices of 5, 15 and 5, negative 5. All right, now the foci, again, we're going to use our nice equation c squared equals that plus that. That's 100 plus 1, which is 101. And that means c is the square root of 101. And what do I do? Again, because it's going up, down, I leave for the foci, I say 5 for the x, and then for the y, it's 5 plus or minus rad 101. Now, that's going to be so close because that's approximately 10. It's really close to 10. So it's going to be like the foci is going to be right above and right below approximately. And we can say the foci is roughly 5, 15.05, and this one is 5, negative 5.05. Okay. And the last thing I'm going to do is I'm going to graph the asymptotes. Again, just as a guiding point for how I'm going to graph this. So what's the slope? And again, it's going through that center point. What's the slope? It's 10, that's the rise, over 1, which is the run. So it's a slope of 10. So there's approximately a slope of 10, and then coming the other way. And then we got a slope of negative 10. Again, these are just approximations. And then starting at the vertex, this first point, we come around and we hug those asymptotes, right? We come around and we hug those asymptotes. Same thing going up. Go up, hug that asymptote. Didn't mean to cross there, but you know, it's tight quarters. Hug that asymptote. And that is how you do it. Done. So for this one, we are going to create the equation based on all of this information, right? We got the vertices here and here. Now, this tells me that the center is right in between the vertices, meaning the center is going to be at 0, 0. So if the center is at 0, 0, I already know it's just going to be a simple x squared and a simple y squared. And because the vertices are left and right, the x squared should be in front, right? And we're going to minus like this. Okay, now I need to know what goes underneath each of these. Well, since the vertices are 3 to the left and to the right of the center, I know that under here is going to be 3 squared. And then the question is, what goes under the y? And we know we have 1 over here. Well, since I know the focus is 5, that is 5 away from the center, meaning c is 5, c squared is 25. And again, that equals the sum of this plus whatever's under here. So we can say 3 squared, which is 9, plus x, and let's call it x squared, right? Because x squared is what goes under here. So now I'm going to subtract 9 from both sides, and I get 16 equals x squared. And it is 16 that goes under here. But to put it in our nice standard form, we'll write that as 4 squared. And that is how you do it. Done. So this one, we got vertices going left and right, right? So we know it's going to be going like this. And our center is going to be in between that 1 and that 11, right, for the x values. So what's in between 1 and 11? Let's take the average. 1 plus 11 is 12, divided by 2 is 6. So I know that my center is at 6, and then we're keeping that same 1 coordinate. So that's my center. So that tells me that, and by the way, since it's going left and right, I know the x is first. So that tells me it's going to be x minus 6 squared on top. And it's going to be y minus 1 squared on top as well to get those center values. Okay, now the question is what goes underneath here. And since it says I have a focus of 12, and this point here is 6, 1, if I have a focus at 12, 1, I know that my c value from 6 to 12 is 6. So c squared is 36. Okay, by the way, we know this is going to equal 1. So c squared is 36. And I know that my a value, or whatever I'm going to put under here, I can figure that out too because I'm going from 6 to 11 or 6 to 1. That's 5 away. So 25 goes under here. So the question is, what goes under here? Now, since I know c squared is 36 and that equals, 25 plus whatever goes under here, I can just say 25 plus x. And now I can subtract 25 from both sides and we get x equals 11. So we're just going to put 11 under here. That's how they actually have it in the back of the book. So this is your final answer. Done. So for this one, we have a center at 4, 2 and a vertex at 9, 2. So immediately I know that the vertex is going right and left, not up and down. So again, we're going to have an x in front. And since we know the center, it's x minus 4 squared, and it's going to be y minus 2 squared. And these are going to be like this and like this, minusing. We know we got a 1 over here. And now what's going to come under the x? Well, I can see that I'm 5 away from the vertex. So 5 squared, or 25, goes under here. Now, what goes under here? Well, I can see from the focus here that square root of 26 is my c value because I'm starting at the center, I'm going square root of 26 to the right. So that means that squared, which is 26, equals 25 plus whatever is under here, which we'll call x. And that means x equals 1, right? Subtract 25 from both sides, and we throw a little 1 under here. And that is how you do it. Done. So for this one, we're going to use the graph to find the equation. The first thing that's great is I can see that my center is at 0, 0, and it's going up, down. So this tells me it's going to be just a y squared and just an x squared. And I know the y squared is first because it's going up, down, as I mentioned, and we know we got a 1 over here. Now we just got to know the values that go underneath here. Well, I can see that this vertex is 4 away from the center. So that means 4 squared, or 16, goes under here. Now, here's the thing. With this nice little nifty box, I don't even need to look at the foci. I don't need to look at anything because if I know this distance horizontally that we go out, that value squared is what goes under the x. So since I can see this nice rectangle, I just go 5 and square it, which is 25, throw it under the x, and that is how you do it. Done. So for this one, we are going to start with our nice center, right? And I can see it goes up, down. So I know the y is going to be first. So the center is negative 1, 0. So I say y minus 0, which is just y squared, over something, minus x minus negative 1, or x plus 1 squared. Okay, and we're going to figure out what goes underneath these in a second. And then this is equal to 1. Okay, now to get this value, which is that distance squared is what goes under here. I look at the y values. I go from 0 to 3, so that's a value of 3. 3 squared is 9. What goes under the x? Well, I don't have that nice box, right? But I do have a foci, right? And the foci is at negative 1, 3 red, 2. And that's from the center. Okay, I've gone up by 3 red, 2. That's my c value. So if I square that, that's 9 times 2, which is 18. It's going to equal this, right, plus whatever goes under here. Let's call it x. And since 9 plus 9 is 18, x equals 9. We got a 9 under here as well. And that is how you do it. Done. So for this one, I see it's going left, right, and I see we got a nice center there. So we're going to start with that. So since it's going left, right, I know my x is first. X minus that value, which is x plus 3, squared over something, minus, and then it's y minus that value, aka y plus 3 squared over some value, and this is going to equal 1. And so now I can see that the distance from the center to the foci from negative 3 to 2 is 5. And that is going to tell me what goes under here. That value, that distance horizontally squared, which is 25. And now we need to know what goes under here. And to do that, we can use the foci. So because the foci, we're adding 5 red to that negative 3 center, I know that that's my c value. So I can make the equation 5 red 2 squared, which is 25 times 2, which is 50, is equal to that plus whatever goes under here. We can call it x, we can call it x squared, because it's technically something squared, but we'll just call it x. And then I can subtract 25 from both sides, and we get 25, and I can place that here. And guess what? That's it. That's how you do it. Done. Okay, so for this one, we're meant to express this as two different functions. I'm going to show you how to do that, but basically, we're trying to isolate y. So first, I'm going to add x squared to the other side. Now, it's x squared over 1, which is the same as x squared. So I'm just going to write it as x squared plus 1. Again, because it's minus, we're adding it. And then I'm going to multiply everything by 9. So we got y squared is equal to 9x squared plus 9. Last but not least, I'm going to take the square root of both sides. Boom and boom. Now, we can kind of simplify this, which is what they did in the back of the book. They said y is equal to, and then they factored out the 9 from the x squared plus 9, so it's x squared plus 1, okay? And then they brought this out as a 3, because square root of 9 is 3. So you can kind of do it like this. And last thing we have to remember is when you take the square root, it makes two functions, meaning plus or minus. And these are the two functions. Now I'm going to show you how this is indeed correct. So here's the original function, and now I'm going to show you with those two functions that it's going to match up exactly. So there's the positive function in green, and you can see it overlaps that purple exactly. And now you can see with the negative version, boom, it covers up that bottom, the bottom half. So there you go. And that is how you do it. Done. So for this one, what we're going to do is we're going to move all the x's and the constants to the other side and keep the y squared minus 2y on the left. And then on the right-hand side, we add 4x squared, add 16x, and add 19. And then we're going to complete the square. We're going to do that by taking half of this and squaring it and adding it to both sides, which is half of 2 is 1, negative 2 is negative 1, squared is 1, so add 1, add 1. Now on the left-hand side, this is a perfect square, and it becomes y minus 1 squared is equal to all of this, and then 19 plus 1 is 20. All right, now we can take the square root of both sides. Before we do that, I'm going to factor out a 4 from this. This is just because this is what they did in the back of the book, so it's not essential, but it does simplify it just a tad. So then we have 4x and then plus 5, right? Because I can divide each of these by 4. And then we have this again, and now to isolate, we're going to take the square root of both sides, okay? And then we have y minus 1 is equal to the square root of this. Square root of 4 is 2, so 2 can come out, and then we got the rest of the radical inside like so. And don't forget, this is a plus or minus situation because we took the square root, right? Last but not least, we're going to add 1 to the other side. And we got 1 plus or minus 2 rad x squared plus 4x plus 5. Okay, now we're going to graph it in Desmos, and we're going to see that this is the exact same as this original equation. So here's the original hyperbola from that original equation. And here's the positive version mapping to the top half. And there's the negative version, the minus with the bottom half. So that's how you do it. Done. All right, so for this one, we're mapping this hedge and this fountain, okay? So it says the hedge will follow the asymptotes y equals x, y equals negative x, and its closest distance to the center fountain is 5 yards. So let's map this out, see what this looks like. So if we kind of assume that the fountain is at the origin right here, and then the asymptotes are these, let's put those in now. And now once we have this, we can figure out which way the hyperbola is going. Now here's the thing, right? It's 5 yards away, but it doesn't say if it's 5 yards above or 5 yards to the left and right. In the back of the book, they have the left and right. So since it's not really clear, let's just roll with that. So 5 yards away at the closest, that means here it's 5 yards away and 5 yards away for the vertices. And again, because we're centered at the origin and we're going left to right as we have chosen, it's going to be x squared and then y squared, and then we're going to set this equal to 1. And then the question is, what are these over? Well, we already know that this vertex is going to be 5 away on the x. So if that's 5 away, I got to put 5 squared or 25 under the x. Now, because the slopes of the asymptotes are 1 and negative 1, this value has to be the exact same as what's under here. So this has to be 25 as well. Now, as we graph this, we're just going to kind of bring it up and hug the asymptotes like so. Boom, come down the other way. And then we do the same thing this side, hug the asymptotes. Not meaning to cross it, but just hugging it. And that's how you do it. Done. So for this one, we got the following asymptotes, slope of 1/2, and then the closest distance is 10 yards. So again, we got a center here. Let's map those asymptotes. And then now it says the closest distance away is 10. And if we're going to go left and right, in this example, which is kind of an arbitrary decision, but that's how they do it in the back of the book. So I'm going to follow that same suit. So 10 yards away, there's a vertex and there's a vertex. Okay, now let's start to piece together this equation. So again, it's centered at 0, 0. So we got x squared and y squared on top like this and like this. And since we're going left, right, the x is in front. Now this distance is 10. That value therefore squared is under x as 100. So what goes under y squared, right? Well, I can look at the slope and I can see it's 1/2, rise of 1/2, okay? And where does that come from? Well, the rise over run is going to be the square root of whatever's under here, okay? So if this is a squared, let's just say, let's call it a, over the square root of that, which is 10, okay? And a over 10 is meant to equal 1/2, all right? So now I can cross multiply and I can say 10 is equal to 2a divided by 2 and a is equal to 5. And that's not what goes under here, but 5 squared, right? Just like this was 10 squared, 5 squared goes under here as 25. Now to graph it, starting at the vertice, we come around and we hug those asymptotes, boom, hug those asymptotes, and we do the same on the left-hand side like this. And that is how you do it, done. So for this one, the hedge is 20 yards away from the center. And again, we're going to assume that it's going to go left and right. That's an arbitrary decision, that it doesn't have to go up and down, but this is the assumption that they've gone with in the back of the book. So if it's centered at 0, 0, where, let's say that's the fountain, we know that this is going to be x squared minus y squared is equal to 1. And then we just got to figure out what these go over. So it says it's 20 yards away, so I know my vertices are 20 to the left and right. And this distance, 20 squared, is what goes under the x squared. Okay, so that is going to be 400. All right. And then now we got these asymptotes. Let's sketch them in. So there's that first asymptote with the slope of 3/4. And there's the second one with the slope of negative 3/4. Again, both going through the origin. So now the question is what goes over here? And the way we get that is because the square root of whatever goes over here over the square root of this should equal this slope, which is 3/4. So what's the square root of that? That is 20, and that's the run, right? So it's rise over run, whatever the rise is. I'll call that x, and that's supposed to equal 3/4. So we can use this to solve 60 equals 4x. Divide both sides by 4, x equals 15. So this value squared is what goes under the y. 15 squared is 225. Okay, great. Now let's sketch it. Starting at the vertices, we just hug the asymptotes, do the same on the left-hand side, boom, and that's how you do it, done. For the following exercises, assume an object enters our solar system and we want to graph its path on a coordinate system with the sun at the origin and the x-axis as the axis of symmetry for the object's path. Give the equation of the flight path of each object using the given information. Okay, so the object enters along a path approximately by the line y equals 2x minus 2 and passes within 0.5 AU of the sun at its closest approach. So the sun is one focus of the hyperbola. It then departs the solar system along a path approximated by the line y equals negative 2x plus 2. So just to get a kind of rough idea, I'm going to first plot these lines. Y equals 2x minus 2. So that has a y-intercept of negative 2 and a slope of positive 2. So it looks something like this, and then let's graph the other one, negative 2x plus 2. And this is really interesting because this tells us our center now. Our center for the hyperbola is right there. It's 1, 0. So the center is 1, 0. Now it says the axis of symmetry is the x-axis, so that means it goes like this and like this, approximately. Okay, that also means that the x is first. So since my center is 1, 0, I can say x minus 1 squared, and then it's going to be y minus 0 or just y squared like this. So now the question is what goes under this value right here, right? And it says it goes within 0.5 units of the sun, and the sun is right here at the origin. So that means that my vertex over here is going to be at 1/2, okay? Because that's going to come and wrap around that sun at the focus, which is at 0. So then that distance from 1 to 1/2 is 0.5, and you're going to square that and put that under the x, which is 0.25, okay? And then now we need to figure out what goes underneath the y. And again, we see that the slope of those asymptotes is 2. So whatever is the square root of what is under y, let's call that a, over the square root of what's under here, which is 0.5, that has to equal 2. So if I multiply both sides by 0.5, I get a equals 1. So a squared is still 1. So now rewriting this one last time, we get x minus 1 squared, and then dividing by 0.25 is the same as multiplying by 4. So we can consolidate that, then that's just a nice y squared, and this equals 1. And that's how you do it. Done. So for this one, once we kind of see the situation and we got these two asymptotes, okay, we got y equals 1/3 x minus 1, y equals negative 1/3 x plus 1. So let's plot those out. And then we got the other one going the other way, negative 1/3 x plus 1. So first I'm going to go ahead and graph these asymptotes for this path, right? So 1/3 x minus 1, negative 1/3 x plus 1. And then this one is negative 1/3 x plus 1. And there we can see our nice intersection, which is the center of the hyperbola at 3, 0. Great. And then it says that it passes within 1 AU of the sun. Here's the sun at the origin, so that's going to be the focus. So it passes within 1 AU. That means my vertex is going to be right here at 1, 0. Now, that means this other vertex is going to be over here, and it's going to look approximately like this as my hyperbola. But anyways, so now we can start to piece this together. We know that the center is 3, 0, so we can be, say, x minus 3 squared over something minus y minus 0, or y squared over something, and this is equal to 1. Okay, so then what goes under here? Well, here's the center, here's the vertex. How far away is it? 1, 2. Okay, so it's 2 away, so 2 squared or 4 goes under here. And then now to get what goes under here, well, look at the slope of these asymptotes. It's 1/3. So whatever goes under here, the square root of that, let's call it a, over the square root of that, which is 2, must equal 1/3, right? Rise over run, y over x. So then to solve for a, multiply both sides by 2, and we get a equals 2/3. So a squared goes under here, 2/3 squared is 4/9. And 4/9 on the bottom is the same as multiplying by that reciprocal of 9/4, so we can rewrite this to make it a little nicer as 9/4. Last but not least, we can multiply everything by 4 to clear those denominators. Again, we don't need to. This is good to go, but just to do it like they did in the back of the book, we get x minus 3 squared, and then times 4 times that clears the denominator. 9y squared equals 4 times that is 4. And that is how you do it. Done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.